So in this lesson, we're going to continue our discussion about the factor theorem, but in relation to zeros. And I want to remind you that you have done stuff with zeros in the past. So recall that a zero of a function is the value or values of x in which f of x is equal to 0. Okay, so for example, so if you wanted to find the zeros of f of x equal 3x minus 1, so if you want to find the zeros of this function, basically all we did was we set this function equal to 0. So we said, so our solution would be this, our work would be 3x minus 1 equals 0. And so if I solve this linear equation for x, I get 3x equal 1, and x is 1/3. So this means that the 0 of f of x, which equals 3x minus 1, is 1/3. That's our 0. So in other words, f of 1/3. So if I found f of 1/3 in place of x, I substitute 1/3, I better get 0. In other words, f of 1/3 must equal 0, and we do. So watch. So let's check. So we have f of 1/3 is equal to 3 times 1/3 minus 1. Well, 3 times a third is 1. 1 minus 1 is 0. Okay? So that's what zeros are. All right? So a zero of a function is a value of x that makes that function equal to 0. Now, the question is, well, how is that related to the factor theorem? Well, let's remind ourselves about the factor theorem. Okay, so remember the factor theorem in the previous lesson, we saw this. We saw that if we have a polynomial and we see that f of c is equal to 0, then x minus c is a factor. So if we got the remainder, remember that was the remainder, so we had the remainder to be 0, then x minus c is a factor. And we also know that if x minus c is a factor, if you're told x minus c is a factor, then your remainder better be 0. F of c must be 0. Okay? All right, so let's look at some ideas or problems dealing with factors and zeros. All right, suppose you're told this. Suppose you're told that f of 2 is equal to 0. Then what is a factor of f of x? So if f of 2 is equal to 0, so remember, according to the factor theorem, if f of c is equal to 0, then x minus c must be a factor. So if f of 2 is equal to 0, then what would be a factor of f of x? So the answer, you would say x minus 2 is a factor. Okay, so if c, this is your c, right? So x minus c. So x minus 2 is a factor. Okay, number 2, what if you had this? What if you had if f of negative 3 is equal to 0, then what is a factor of f of x? All right, so remember, it's got to be, remember, if this is c right here, then it's got to be x minus c. Okay, so the answer in this case would be, so the answer, you would say x plus 3 is a factor of f of x. All right, so x plus 3, because remember, it's got to be x minus c. So if c is negative 3, this becomes x minus a negative 3, which is x plus 3. Okay? All right, so just make sure you write as x plus 3, though. All right, so that's important. So if c is 2, your factor is x minus 2. If c is negative 3, your factor is x plus 3. Okay? All right, now let's look at this. So number 3 is written a little bit different. It just says this: if 4 is a 0 of g of x, then what is a factor of g of x? All right, so if 4 is a 0 of g of x, then x, so the answer, you would say x minus 4 is a factor of g of x. Okay? All right, what about number 4? So number 4, if negative 7 is a 0 of h of x, what is a factor of h of x. So if negative 7 is a 0 of h of x, then what is a factor of h of x? All right, so your answer. And I need you to say it like this. I need you to say your factor is going to be x plus 7. Okay, so x plus 7 is a factor of h of x. And the reason, so let's remind ourselves about the reason. So the reason is because, remember, it's got to be x minus c, right? So if c is negative 7, you're going to say x minus a negative 7, which equals x plus 7. And so that's what you write. All right, so you must say x plus 7. All right, so that's number 4. All right, so let's look at number 5. So number 5 says this. If f of x is 3x squared plus 10x minus 8, and you're told that f of negative 4 is 0. So remember, that means that negative 4 is a 0, right? So negative 4 is a 0. So if f of negative 4 is equal to 0, then we know one of our factors. It says find all factors of f of x. And so we're going to go ahead and factor f of x. All right, so this is our work. All right, so listen carefully. So since f of negative 4 is equal to 0, then that means that x plus 4 is a factor of f of x, right? Okay, so we found one of them. So one of our factors is x plus 4. But I got to find the other factors, and there could be one or more, okay? Well, okay, so in this case, the largest degree is 2, so there can only be one more, but this could have been cubic or a 4th degree polynomial and so on. So we're going to find all of them. Okay, so this is what we're going to do. So since I know I'm going to get a remainder of 0, I'm going to go ahead and use synthetic division to kind of simplify this. So I'm going to get negative 4, and I'm going to put this in descending order. There's no missing terms, so I have 3, 10, negative 8. Now remember, we're supposed to get a remainder of 0, so keep that in mind. So I bring down the 3. Negative 4 times 3 is negative 12. I add, I get negative 2. And I multiply. Negative 4 times negative 8 is a positive 8, and I get a remainder of 0. Okay, so I knew I was supposed to get this. But here's the thing, though. So remember in a previous lesson, these are the coefficients of our other factor. So the coefficient of our other factor, now remember this is x squared here. All right, so I'm dividing by x plus 4. So negative 4x plus 4. And so I'm 1 degree less. So this is going to be 3x, and this is our constant. All right, so what I found is this. So the other factor of f of x is 3x minus 2. All right, so I found the two factors. So one of them is x plus 4, given the fact that f of negative 4 is 0, so one of the factors must be x plus 4. So I use this information to use synthetic division, and so then I have the other factor. So these are the coefficients of the other factor, okay? And so then we can say f of x, which equals 3x squared plus 10x minus 8 is equal to x plus 4 times 3x minus 2. All right? And so if you follow this out, you'll get 3x squared plus 10x minus 8. All right, so that's number 5. Let's look at another one like this. Now, this is going to be important in another lesson that we're going to do. This idea here is called the rational zeros theorem. So that the rational zeros theorem can help us to factor and to find zeros of polynomials that are much more difficult than this. All right, so that's called the rational zeros theorem. So that's going to be another lesson. All right, so let's do another one like number 5. Okay, so let's number 6. Number 6 says this: factor this polynomial, x cubed minus 19x minus 30, given that f of 5 is equal to 0. All right, well, let's think of our process. So remember, according to the factor theorem, if f of 5 is equal to 0, okay, if f of 5 is equal to 0, then since f of 5 is equal to 0, then that means x minus 5 is a factor of f of x. Okay? So x minus 5 is a factor of f of x. So now I got to find the other factors. So I know one of them. Okay, I got to find the others. All right, so we're going to use synthetic division. So I'm going to put 5. And then notice I am missing x squared, so I'm going to put a 0 for this that missing term. So I have 1, 0, negative 19, negative 30. All right, so let's bring down the 1. 5 times 1 is 5. Add, I get 5. 5 times 5 is 25. Negative 19 plus 25 is 6. 5 times 6 is 30. Add, you get 0. You knew you had to be 0, right? I mean, you knew you had to have 0 here because that was what you were told. Now, this is our remaining polynomial. So let's think about what those variables are. So you see, this is x cubed, right? That's x cubed. So this will be x squared. This will be x, and this is our constant. All right, so here's what I have. So far I have this. I have f of x, which equals x cubed minus 19x minus 30, will equal this factor, x minus 5, times this polynomial, 1x squared plus 5x plus 6. And now look, remember in a previous course last semester, when you factored, remember you were always told to factor completely. See this trinomial right here? I can factor this further. So this becomes x minus 5 times, and then this, when I factor this, this will be x plus 3 times x plus 2. So there's your answer. So x minus 5 times x plus 3 times x plus 2. So those are your factors. All right. So all I did was I just used the factor theorem. So let's talk about it again. So according to the factor theorem, if f of 5 is equal to 0, then that means x minus 5 is a factor. I can use synthetic division. I can use synthetic division to break this down into a simpler polynomial times this factor. So I have this factor, x minus 5, and then I know that since f of 5 is equal to 0, I better have a remainder of 0. So I use synthetic division, and I get this polynomial left. So what that means is that this polynomial is going to be this factor times this factor. But I can rewrite this factor into two simpler factors. So remember, always factor completely. All right, let's do another one. So number 7. Okay, so it's number 7. So let's factor this polynomial, given that f of 4 is equal to 0. And we can just use the factor theorem. That's all we need to do. And this is simple enough to where just using one factor will get you to find all the others. All right, so let's talk about this. So according to the factor theorem, since f of 4 is equal to 0, then x minus 4 is a factor of f of x. Okay? So then I can use synthetic division to break that down a little bit further. So I have 4, and then I'm not missing any terms, and it's already in descending order. So I have 2, negative 1, negative 25, negative 12. All right, now remember, according to this, I better get a 0 here, right? Because that's what my remainder is 0. All right, 4 times 2 is 8. Add, I get 7. 4 times 7 is 28. Add, you get positive 3. 4 times 3 is 12. Add, you get 0. Okay? Now, what that means, see this right here, those are the coefficients of the other polynomial. So what that means is this. So f of x, which equals this, 2x cubed minus x squared minus 25x minus 12 is going to be this factor, x minus 4, times the coefficients, now times this factor here. And so those are the coefficients of that other, let me raise this a little bit higher. So this right here, the coefficients of the polynomial that goes here. So remember, this is x cubed, so this is going to be x squared. So x squared, x, and your constant. So this will be 2x squared plus 7x plus 3. But remember, you can factor this trinomial. You all know how to do that. So that'll be x minus 4 times, and let's see, that's going to be, let's see, the last sign's positive, so these signs will be the same, both going to be positive. And I need the 3 and the 1, so the 3 is going to go here, the 1's going to go there. And so there's your answer. So this polynomial can be written as a product of these factors. And so I use the factor theorem. All right. So I use the factor theorem. Given that f of 4 is 0, then x minus 4 is a factor. So I use synthetic division to rewrite this polynomial into a simpler polynomial. So 2x squared, 7x, and 3. Okay? And then you factor that further and you're done. All right, you want to do one more? Let's do one more. Now, in another section, I'll tell you this. You might say, well, that's simple. Yeah, that's simple because we haven't talked about another section yet. So we have to deal with simple problems here. So in another lesson, we are going to talk about the rational zeros theorem. The rational zeros theorem. Okay, so let's do number 8. So number 8, you want to factor f of x equals 3x cubed plus 2x squared minus 19x plus 6, given that f of negative 3 is equal to 0. All right, so according to the factor theorem, since f of negative 3 is equal to 0, then that means x plus 3 is a factor of f of x. Okay, so since x plus 3 is a factor of f of x, I can use that and synthetic division to find the remaining factors. So let's do that. So I have negative 3, and let's see, I'm not missing any terms, and it's already in descending order, so let's put the coefficients. So I have 3, 2, negative 19, and 6. All right, so when I use synthetic division, keep in mind that my remainder better be 0 because that's what this says, right? Okay, but that's going to help us to find the other polynomial, and we can factor the result. So bring down the 3. Negative 3 times 3 is negative 9. Add 2 and negative 9 is negative 7. Multiply negative 3 times negative 7 is a positive 21. Add, I get, let's see, what's that, 2? Multiply, I get negative 6. Add, I get 0. All right? So what that means now is this. See, these right here, those are the coefficients of that quotient, that other polynomial. Okay, so now this is what we have. We have that f of x, which equals 3x cubed plus 2x squared minus 19x plus 6 is going to equal this factor times the polynomial of this quotient right here, times this quotient. So remember, if this is x cubed, then this has to be x squared, and this has to be x, and that's our constant. Okay, so I get x plus 3 times 3x squared minus 7x plus 2. And then from there, I can factor this trinomial. So let's go ahead and do that. So I get x plus 3, and let's see what we get. So this will be 3x and x. The last sign's a positive 2, so that means if that's positive, these have to be the same sign, and they're both going to be negative. And let's see, it looks like the 2's going to go here, and the 1's going to go here. And so there you go. There are your factors. X plus 3 times 3x minus 1 times x minus 2. And that's all you do. So that's using a factor theorem. All right, so that is going to be the end of this lesson. All right, so that's going to be the end of this lesson that talked about factor theorem and zeros. So remember, according to based on the factor theorem, we saw that if you're told that 4 is a 0 of g of x, then that means that x minus 4 is a factor of g of x. And then knowing about zeros and factors, then we could use the factor theorem to factor polynomials given just one zero, given this one factor. All right, so given this, we saw that if negative 4 is a 0, then x plus 4 is a factor, and then we could easily find the other factors. And that's what we did for 6, 7, and 8 as well. All right, so that's the end of this lesson on factor theorem and zeros.